connected to a particle of mass m and the other end is connected to a small peg on a smooth horizontal table. If the particle moves in a circle with speed v, the net force on the particle will be. Okay, so the options are actually t plus mv square by l and t bt plus and cst minus mv square by l. So smooth horizontal table, net force along the center, circular motion. Okay, right. So as usual, we'll do it in three parts. First, we'll visualize the concept. Second, we'll see the free body diagram. And third, we'll apply the Newton's second law of motion. If we were to visualize this, this is what we have here. We have a table, right? And this is the peg, the wooden peg or any peg. Now this here represents a string and this is the ball or the bob, whatever it is, or particle m, anything. Now what is this bob doing? This bob is exhibiting circular motion within the table. This bob is exhibiting circular motion like this within the plane of the table. So if you were to see the top view, this would look like table, the surface of the table, right? This actually represents the surface of the table. This is the peg, thread, and now we have the bob executing circular motion like this, or the particle executing circular motion. Now let us see the various forces acting on this bob. So if we were to analyze the various forces acting on it, we know that the first primary force acting would be mg, and then we have reaction on the bob or on the particle due to the surface, right? Okay. So that is the force acting in the vertical direction. And which force is acting along the horizontal direction? See, since the string has a point of contact here, we know that tension is always away from the point of contact, and therefore the tension direction is towards the center. Now, see, this is the circular motion actually traced by it, right? Circular motion. This is how the object is tracing the circular motion, and this is the center of it. Now, when we say center, we definitely have radius, right? We definitely have radius. And when we say radius, since this is the string, we can say that length of the string, let me write it down here. Length of the string is actually equal to the radius of the circular motion, right? Radius of the circular path. Radius of the circular path. Therefore, we can say that r is actually equal to L here, right? So instead of r, we can write here length of the string, which is, according to the given equation, L. Okay, right. Now we also know that when the object is in a circular motion, there is an acceleration which is mv square by r. Now what is centripetal acceleration? See, this is the concept which I would say the question is trying to test on you. Centripetal acceleration means that acceleration that is pointing towards the center. Centripetal towards the center. So what is centripetal force? Centripetal force is that force that is pointing towards the center of the circular motion. Okay, I repeat. So what is centripetal acceleration? Acceleration that is pointing towards the center. What is centripetal force? Any force that is pointing towards the center. Now let us see the various. Okay. If we see in the various forces, now let us see how to apply the Newton's second law of motion. So we'll apply Newton's second law of motion both in vertical and in horizontal direction. So we know that sigma Fy is equal to may and sigma Fx is equal to max. Since there is no vertical motion in the since there is no motion in the vertical direction, we can say that net vertical motion is equal to 0, and therefore Ay should be equal to 0. And if Ay is equal to 0, then we have sigma Fy is equal to m into Ay is equal to m into 0 is equal to 0. And what are the various forces acting in the vertical direction? We have N and mg, and therefore we can write here that N is equal to mg. But then this has nothing to do with the question given. Why? Because we have been asked to find out the we have to find out the force that is acting along the center. These two are definitely not acting along the center. Now, if we had write sigma Fx is equal to m into ax, right? Sigma Fx is equal to m into ax. So we can write a sigma Fx is equal to m into, instead of ax, what do we have here? Instead of ax, what we have is the centripetal acceleration. So we have m into ac. So instead of ac, we have instead of centripetal acceleration along x component, we have AC. Now, what is the value of AC? So AC we know is mv square upon r. What is mv square by r here? We just said that r is basically equal to L, because length of the string is basically the radius of the circular path. Therefore, we have mv square by r will now be replaced by mv square by L. Now let us see the sigma fx part. See which forces are acting along the x direction. So maybe we can draw one more. Maybe we can draw one more free body diagram here. So this is the bob, right? This is normal reaction. This is mg acting, and we only have one force that is acting towards the left, which is tension, right? Is there any other force? No, which simply means that the only force acting along the x direction is tension. Sigma fx actually tension alone. So tension is equal to mv square by L. What does it mean? See, it means that it actually means that mv square by L, or let me put like this. Let me retake this equation one more time. See, if sigma fx is equal to m into AC, right? If sigma fx is equal to m into AC, what I should do is I should write sigma fx as sigma fac. Oh, sorry, sigma fc. Now, what is sigma fc? Sigma fc is actually the what we call as the centripetal force, because centripetal force will be mass into centripetal acceleration. Very simple, right? So what if you just try to connect these two? What does it mean? It means that the centripetal force is actually the tension in the string. So if we were to write it otherwise, there is no special force what we call as the centripetal force, right? So here tension acts as the centripetal force. Students often ask me which force is centripetal force. How do we mark centripetal force? How do we mark centrifugal force? See, centripetal force is not a force on its own. Centripetal force is any force. I repeat, centripetal force is any force that is acting along the center of the circle where which the circular motion is taking place, and it is this force which causes the circular motion as such. I'll give you a couple of examples extending this question, and then things will become very clear to you. So if you were to see this, this satellite here is in circular motion. Why? Because it is actually exhibiting a, so give me a minute. So if you see this, this is the direction of the circular motion. The satellite is moving around the Earth, and at this point, if you try to understand this, the satellite is in a circular motion because there is definitely a centripetal force acting here, right? Yes, the electron is spinning around the nucleus because definitely it is exhibiting a circular motion. Therefore, there has to be a F centripetal. When a car is moving in a circular path, so if you were to, if you just complete this, so if you consider this as a road, it simply means that it is a circular road here, right? It's part of a circular road, and therefore when the car reaches this position, definitely yes, there is some centripetal force which is acting towards the center. Now all of these are F centripetal. But what is this centripetal force? In this case, this is the friction offered by the road which acts as what it is. Exactly, this F centripetal is actually equal to the F gravitational. Again, here F centripetal is equal to the F. Oh, wait, what happened? Is equal to the F electrostatic, and here F centripetal is actually equal to the frictional force. Right, so that's the concept that the question is trying to evaluate here. Well, something that we need to discuss in circular motion. I just said it here because, if you are here for a question, make sure that you understand what the question is demanding. It's not demanding you for a solution, it's demanding whether you know the concept regarding the question. Okay, so next up is a question based on connected motion. Motion of police. Okay, motion of connected bodies. So very good question.